All right, welcome and thank you for joining me today. In today's lesson, we are going to do a bunch of examples of stoichiometry. In the previous video, we learned about what stoichiometry is and the process of how to do it and the steps. And so now we're just going to do a bunch of examples of stoichiometry. So I know that the title there says mole ratio. I forgot to change it, and so I'm just going to go with it. So it should say stoichiometry examples, but it is what it is. So let's look at our first example. We have Mg2HCl yields MgCl2 and H2O. This is our chemical equation. Now you'll notice that since there is a coefficient in front of the HCl, that tells me that this is already a balanced chemical equation. So I'm going to move on because step one is to make sure we have a balanced chemical equation. So if I have 83.9 moles of magnesium, how many moles of magnesium chloride will be made? And so this is how we do this. So first we have a balanced chemical equation, and so we're going to start off with the number that they gave us, 83.9 moles of magnesium, and we're trying to find how many moles of magnesium chloride that is. Well, this is a very simple stoichiometry problem. It's just using the mole ratio. So I'm going to start with the number I'm given, 83.9 moles of magnesium, and then we're going to, step one is to convert to moles. Well, it's already in moles, so I don't have to do that. So then I need to set up my mole ratio. Well, if I have moles of magnesium on the top, I need moles of magnesium on the bottom. And I'm trying to find moles of magnesium chloride, so I'm going to put moles of magnesium chloride on the top. And so that the moles of magnesium cancel, and I have changed my substance to moles of magnesium chloride. So now the numbers that go here come from right up there, my balanced chemical equation. Well, the coefficient of magnesium is 1. The coefficient of magnesium chloride is 1. So this is actually a 1-to-1 ratio. And so I simply multiply things out and it doesn't change. It's 83.9 moles of magnesium chloride. So that is a very, very simple one because it's a mole-to-mole stoichiometry. All we need is the molar mass, or sorry, the mole ratio of our balanced chemical equation, and we can multiply it out. And since it was a 1-to-1 ratio, our numbers are simply the same. That one was a pretty easy one. They're not all that simple, but we're going to keep going. Our next example, how many grams of magnesium are needed to completely react with 6.0 moles of HCl? So in this one, I'm given 6.00 moles of HCl, and I want to find how many grams of magnesium are going to be required. So again, just like any other conversion, I start with what they give me in the problem, 6.00 moles of HCl. And since I'm doing stoichiometry, I have my balanced chemical equation, so the first thing I'm going to do now is convert to moles. Well, it's already moles, so I don't have to convert to moles. So now my next step is to set up my mole ratio. I have moles of HCl on the top, so I need to have moles of HCl on the bottom. And since I'm trying to find magnesium, I'm going to put moles of magnesium on the top. Now, I'm trying to find grams of magnesium. Why did I put moles of magnesium here? Well, the reason is because this is the mole ratio. In order to be a mole ratio, it has to have moles on both the top and the bottom. So we have to make sure that we have our mole ratio set up correctly. Now, the numbers that go here come from my balanced chemical equation. You'll notice that the coefficient of magnesium is a 1 and the coefficient of hydrochloric acid is 2. So now it's not a 1-to-1 ratio, it's a 1-to-2 ratio. But you'll see that my moles of HCl are going to cancel out. And now I have moles of magnesium. But I want grams of magnesium. And so that's where the next step of stoichiometry is to convert to the desired unit. Well, if I have moles of magnesium on the top, I'm going to put moles of magnesium on the bottom. And since we're doing a conversion now, it's 1 mole of magnesium is equal to the molar mass of magnesium, which I get off the periodic table, and that's 24.305. So my moles of magnesium are going to cancel out. I'm left with grams of magnesium, which is what the question asked for. And so now I'm going to multiply 6 times 24.305 divided by 2. And when I multiply and divide, that gives me 72.915, but I start with only 3 significant figures, so I need to have only 3 significant figures. So 72.9 grams of magnesium is my final answer. So again, convert to moles. It was already in moles, so I didn't have to do that. Set up my mole ratio, and then convert to the desired unit, which in this case was grams. Now in this example, we're going to start with 24.96 grams of HCl. So I have 24.96 grams of HCl and an excess of magnesium. How many liters of hydrogen will be produced, assuming the gas is at STP, so that we can use that molar volume. So if I have 24.96 grams, I'm going to start there, 24.96 grams of HCl. So the first thing I need to do is convert to moles. So if I have grams of HCl on the top, I need to have grams of HCl on the bottom. And so I find the molar mass of hydrochloric acid is 36.461. So that's 36.461 grams of HCl is equal to 1 mole of HCl. Notice it's 1 mole here because I'm doing a conversion. Grams of HCl cancel. I have moles of HCl. So I've done my first part of converting to moles. Now I set up my mole ratio. If I have moles of HCl on the top, I'm going to put moles of HCl on the bottom. And since I'm doing a mole ratio, it's going to be moles on top, and I'm trying to find hydrogen. So it's going to be moles of hydrogen on the top. So now my moles of HCl will cancel, but I need numbers here. So I look at my coefficients of my balanced chemical equation. In HCl, the coefficient was 2. For H2, the coefficient is 1. Again, a 1 to 2 ratio. So my moles cancel. So now the last step is to convert to my final desired unit. Well, I want liters. So I have moles of H2, so I'm going to put 1 mole of H2 is equal to 22.4 liters of H2 at STP. So now my moles of H2O cancel out. I'm left with liters, which is what the question asked for. So now I'm going to do my math. And again, I multiply the numbers on the top and I divide the numbers on bottom. So 24.96 times 22.4 divided by 36.461 divided by 2. I put all that in my calculator and I get 7.667151203. And hopefully you know by now that we're not going to leave it there. We have to convert or round to the proper number of significant figures. Well, my question I started with had 4 significant figures, so I'm going to have 1, 2, 3, 4 significant figures, 7.667 liters of H2. And there is the problem. Now, this is the longest type of stoichiometry problem that you're going to have as far as the number of steps. We did all of the steps here. We converted to moles. We set up our mole ratio. We converted to our final unit. We write it all out, we do the multiplication, and we round to proper significant figures. Now, our next example, we're going to do something with the photosynthesis reaction. So the photosynthesis reaction uses carbon dioxide and water to make a sugar and oxygen gas. So how many grams of sucrose, that's what the sugar is, that hydrocarbon, are produced from 224 liters of CO2. So I have 224 liters of CO2, and I want to know how many grams of sucrose. That's the C12H22O11. How many grams of that am I going to make? Okay, so I start with, my number that I start with is 224 liters of CO2. And the first thing I need to do is convert it to moles. So if I have liters of CO2 on the top, I'm going to put the molar volume, 22.4 liters of CO2 on the bottom. Even though the question didn't say so, we're going to assume it's at STP. And that equals 1 mole of CO2. So I've converted from liters to moles of CO2. So now I need to set up my mole ratio. So if I have moles of CO2 on the top, I'm going to put moles of CO2 on the bottom. And it's a mole ratio, so I'm going to have moles on the top, and my moles are going to be of this one because that's what I'm trying to convert to. So I'm going to put the moles of sucrose on the top. So now to figure out what numbers go here, I look at the coefficients of my balanced chemical equation right there. So carbon dioxide's coefficient is 12 and sucrose coefficient is 1. So this is a 1 to 12 ratio. So my moles of carbon dioxide have canceled, and now I have moles of sucrose. I want grams of sucrose, so I have to convert from moles to grams. So if I have moles of sucrose here, I'm going to put 1 mole of sucrose, C12H22O11, and the molar mass of sucrose, is 342.297 grams of sucrose. I'm not going to write it because I don't have room. Now you'll see that the moles of sucrose cancel and you're left with grams of sucrose, which is what the question wanted. So I'm now going to do my multiplication and division. So 224 times 342.297 divided by 22.4 divided by 12. I do this in my calculator and I get an answer of 285.2475, and I need 3 significant figures, so that is going to give me 285 grams of sucrose. And that is my final answer. So for this example, we're using the same equation. How many liters of carbon dioxide are taken out of the atmosphere for every kilogram of oxygen that is produced? So this time I'm actually giving you a quantity that is on the right side. I'm giving you how much product is made and asking how much reactant is required. So this time I'm given a kilogram, which is 1,000 grams of oxygen, and I want to know how much or how many liters of CO2 that is. Okay, so again, I start with the number that I'm given in the problem, 1,000 grams of oxygen, and I first have to convert that to moles. So the molar mass of O2 is 31.998 grams of O2 is equal to 1 mole of O2. And now I set up my mole ratio. If I have moles of O2 on the top, I put moles of O2 on the bottom. I'm converting to carbon dioxide, so it's a mole ratio, so I put moles of CO2 on the top. My numbers come from my balanced chemical equation. It's 12 moles of O2 and 12 moles of CO2. Those are the coefficients in my balanced chemical equation. And then I convert to my final unit. If I have moles of CO2 on the top, I'm going to put moles of CO2 on the bottom, and I'm converting to liters, so it's 22.4 liters of CO2. So the grams cancel, moles of O2 cancel, moles of CO2 cancel, I'm left with liters of CO2. So now I'm going to do my multiplication, 1,000 times 12 times 22.4 divided by 31.998 divided by 12. Now you can type that all into your calculator and you'll get the same answer, but you can notice that this is 12 divided by 12, so that whole term kind of goes away. And so it's really just 1,000 times 22.4 divided by 31.998. And when I do that, I get an answer of 700.0437527. But I started with only one significant figures because I just said 1 kilogram. That's not very specific, not very precise. So I have one significant figure, so my answer gets rounded to one significant figure, 700 liters of CO2. So for every kilogram of oxygen that a plant uses, we take 700 liters of CO2 out of Earth's atmosphere. That's kind of cool. Now for this example, once again, using the same chemical equation, this time if a plant uses 396 grams of water, so I have my 396.6 grams of water, what mass of sucrose? So now I want grams of C12H22O11. How many grams of sucrose would be produced? Okay, so again, as always, we start with 396.6 grams of water. The number I start with, I need to convert it to moles. So I'm going to put the molar mass of water on the bottom, and that equals 1 mole of water. And now I'm going to do my mole ratio. If I have moles of water on the top, I'm going to put moles of water on the bottom. And since I'm converting to sucrose, I'm going to have moles of sucrose on the top. And my coefficients are 11 and 1. Those are the coefficients of those substances in the reaction. And now I want grams, so I'm going to convert from moles to grams. So I have 1 mole of sucrose, and that's going to give me 342.297 grams of sucrose. So the grams of water cancel, moles of water cancel, moles of sucrose cancel. I'm left with grams of sucrose. So now I do my multiplication and my division. 396.6 times 342.297 divided by 18.015 divided by 11. And when I do all that division and multiplication, I get 685.06038. But I want 4 significant figures, so I need to round this to 1, 2, 3, 4 significant figures is 685.1 grams of sucrose. And there is my final answer. So you'll notice for this reaction, we have to actually balance the equation. So let's just review how to do that. If I have sodium, and there's hydrogen is in 2 different compounds here, so I've got hydrogen, and CO3, it doesn't stay CO3, so I know I've got carbon and oxygen in there, but SO4 stays SO4, so I'm going to have SO4 and treat it like a element. So on this side I have 1 sodium, and over here I have 2 sodiums. I have 1, 2, 3 hydrogens, and over here I have 2 hydrogens. I have 1 carbon over here and 1 carbon over here, so they're good. I have 3 oxygens over here, not counting the ones that are in sulfate. So I have 3 oxygens here, and I have 2, 3 oxygens over there. And I have 1 sulfate and 1 sulfate. So these 3 are already balanced, but these 2 are not. So let's do the sodium first. If I put a 2 right here in front of that sodium, that gives me 2 sodiums, but it also gives me 2 more hydrogens. So I have 2 hydrogens here, plus those 2 is a total of 4 hydrogens. And this is 2 times 3 is 6 oxygens. So I have 6 oxygens there, and 2 times 1 is 2 carbons. Okay, so I have made everything a mess, but not to worry. Let's just see what I can do here. If I have 4 hydrogens here, well, if I put a 2 right there, that gives me 4 hydrogens. So now I have 4 hydrogens, but it also gives me 2 oxygens here, plus those 2 is 4 oxygens. And my carbons now are not balanced, so I'm going to put a 2 right there to give me 2 carbons, and that gives me 2 times 2 is 4, plus these 2 is 6 hydrogens, or oxygens, sorry. And so now 2 and 2, 4 and 4, 2 and 2, 6 and 6, 1 and 1. It is now balanced, so my coefficients are 2, 1, 1, 2, 2, respectively. And so now I have this as my equation. So now with that equation, we can answer some stoichiometry questions, because again, the first step to stoichiometry is making sure you have a balanced chemical equation. So now how many grams of sodium sulfate are produced from 3.96 moles of sodium bicarbonate? So I'm going to just go ahead and go with my starting point, 3.96 moles of sodium bicarbonate, that's the NaHCO3, and I want to find out how many grams of sodium sulfate, that's the Na2SO4. So that's what I'm trying to figure out. So 3.96 moles of NaHCO3. Step 1, convert to moles. Well, it's already in moles, so I'm simply going to set up my mole ratio. I have moles of NaHCO3, and I'm trying to find sodium sulfate, so I'm going to put moles of sodium sulfate on the top, and the coefficients of my equation that I just balanced are going to tell me what those should be. So the coefficient of sodium bicarbonate is 2, and the coefficient of sodium sulfate is 1. And the question wants grams, so my moles of sodium bicarbonate cancel, and so I have moles of sodium sulfate. So I need to convert my moles of sodium sulfate to grams of sodium sulfate. So the molar mass of sodium sulfate is 142.042 grams of sodium sulfate. And so now my moles of sodium sulfate cancel. I'm left with grams. So now I can multiply my numbers and divide by 2, and that gives me an answer of 281.24316. But then I need the proper number of significant figures. I have 3 significant figures here, so my answer needs 3 significant figures. So 281 grams of sodium sulfate are what are required to solve that problem. Now for this example, we're going to have the same chemical equation that we just had, but now what mass of sulfuric acid is needed to completely react with 87.6 grams of sodium bicarbonate. So this time I have 87.6 grams of sodium bicarbonate, and I want to know how many grams, or what mass, that's grams, of sulfuric acid are needed. Okay, so I start with 87.6 grams of sodium bicarbonate, and I have to convert that to moles. So I need the molar mass of sodium bicarbonate, which is 84.006 grams of NaHCO3 is equal to 1 mole of NaHCO3. So I've converted from grams of sodium bicarbonate to moles of sodium bicarbonate. And now I'm going to set up my mole ratio. If I have moles of sodium bicarbonate here, I'm going to put moles of sodium bicarbonate on the bottom, and I'm trying to find sulfuric acid, so I'm going to have moles of sulfuric acid on the top. And then I look at my coefficients of my chemical equation. Coefficient of bicarbonate here is 2. The coefficient of sulfuric acid is 1. And then I need to cancel out my moles. And so now I need to convert from moles of sodium or hydrogen sulfate, sulfuric acid, to mole or grams of sulfuric acid. So I have 1 mole of sulfuric acid is equal to 98.078 grams of sulfuric acid. And I went off the screen, sorry. So my moles will cancel. I'm left with grams of sulfuric acid. So now I multiply 87.6 times 98.078 divided by 84.006 divided by 2. And that gives me an answer of 51.13701,878. And then we round it to our proper number of significant figures, which is 3. So 1, 2, 3 is 51.1 grams of sulfuric acid are needed to completely react with 87.6 grams of sodium bicarbonate. So in this video, we have gone over 8 examples of stoichiometry, some more complicated than others, but hopefully you've seen the process. And I know that in this one, I didn't go through how to calculate the molar mass of each one of those compounds. I just gave you the molar masses of them. Make sure you know that you're going to have to calculate the molar masses of each of the compounds when you're trying to solve the problem. So that's an extra step in there that you're going to have to do. It's part of the converting to moles, and converting from moles to grams is finding the molar mass of your substances. So make sure you know how to do that correctly. So hopefully by now, after you have watched all these examples, you get an idea of how stoichiometry works and you can do it on your own. Thanks for watching. Have a day.